Tonight's tinkering is assisted by Jaipur Amber Ale from Brazen Hall Brewing Company in Winnipeg. They describe it as being deep in color and rich in flavor, a brown ale with subtle chocolate caramel and some earthy yet fruity notes. So tonight I'm going to be starting my tinkering with these solenoids that I got a while ago. I've got a couple of different versions. I've got 12 volt and 5 volt ones. So these both have the same physical form factor. The yellow taped ones are 5 volts and the blue taped ones are 12 volts. I just want to experiment with them a little bit and maybe get started on my project, although the project that I had envisioned for these things needs a lot more solenoids. So right now I'm just going to get some basic preliminary messing around and experimenting figured out. The first thing being just to verify the voltage and current that these things need. So I got my power supply set to 5 volts with a 1 amp current limit. And this one, I think, yeah, this one's the 5 volt one, so I'll just do that. It's nice and quiet when it moves. You can hear it skittering across the bench, but that's pulling 750 milliamps or thereabouts. Yeah, I think that'll work somewhere in there. Let's try the other one at 12 volts. And that one seems to be, well, seems to go just about as well. And that's only 400 and some milliamps. So maybe I will go with the 12 volt ones. Okay. Just for convenience, I'm going to solder on a couple of these breadboard jumper wires. These are ones that I just cut up to, you know, use for this purpose. They're cheap, they're plentiful, I've got lots of them, so why not? It's easier than trying to crimp onto these little tiny wires. There, that's a little bit less fiddly to mess with. Okay, so we'll carry on from here. If I'm going to be driving these things, I can't drive them straight out of a microcontroller. I suppose I could use a push button, but that kind of defeats the purpose. If I'm going to be using a microcontroller, I might as well use a transistor to drive the thing, because I can't connect this directly to a microcontroller. That's going to blow shit up. So just put just a cheap little NPN transistor in here, and then to control the transistor, I've got just a little push button here, got a 1K resistor there, just to limit the base current a little bit so I don't overload the thing. So there we go, and then ground goes to the collector, the emitter can go to that can go up there, and right, there's going to be a magnetic field built up in here, and then when it shuts off, just like a relay, it will collapse that magnetic field and give me a pulse of electricity back through there. So we need a diode to protect the transistor and anything else that's going on. The diode wants to be reversed across there, so I will put the anode to the negative side here and the cathode to the positive side, band over there, so voltage naturally can't run that way because it's a diode. But when that field is collapsing, that will be going this way and it will just short it out. That's how basic electronics works. So I'll turn this guy back on, and there we go. Perfect, that's exactly what I wanted. For those who are wondering, here is what this looks like. Transistor, base, collector, emitter. Right, so emitter goes down to the minus voltage. There is my 1K there. Up here this is essentially an open collector circuit. So up there we have the solenoid, and that goes over to the positive, and then we have the diode like that. So again, under normal circumstances that diode won't flow any power, but when this coil field collapses, it will send a spike back through here and it'll just be shorted out through the diode. No problem. Then there's this 1K here, goes through a switch to the positive voltage. That's what it is. Super duper simple. However, I don't want to be pushing a button to control this thing. I think I'll leave the button there. I want to be using a microcontroller such as this Arduino Nano. I'm going to pull this off. Ow, ow, ow. Because that doesn't fit in there properly. Due to poor planning. So, we will delete that switch for now. If I need it later, I'll put it back on. And instead of going to the switch, we will just go from a GPIO pin to there, to the base of that. Where's some more wires here? We'll connect the ground of that to the common ground. But the power for this thing, we're not going to take off the 12 volts. Actually, we can, because there is a V in, which should, yeah, hang on. Let's grab another Nano here. These Nanos have a voltage regulator on them. So the V in can drop the voltage from 12 volts down to the 5 volts that the Nano needs. So we can use that. V in up to the 12 volts. That's over to there. That's ground to there. I think that's all we need. I've already got this thing programmed with essentially the blink sketch, except for I've shortened the on time and lengthened the off time. So it should, every 2 seconds, make a quick little pulse there. Just like that. So now I haven't really explained what I want to do with this. I want it to be a kind of a chime thing. Sort of like a doorbell, a musical doorbell. Way back, early on in my electronics tinkering, and when I was a teenager still, my parents got me the old Heathkit electronic doorbell kit, which was an awesome and frustrating thing, and it basically made synthesized analog chime sounds when you could program it in with a bunch of jumper wires to make different tunes and stuff. I want to do something similar, only using an Arduino and actual chimes. Now then, I don't have a xylophone that I can take apart or anything, but what I do have is an assortment of metal rods. And I'll just quickly experiment with which one I like the sound of, and you guys can give your opinion as well. The threaded rod is probably not going to be. This is a piece of 5/16 steel. This is 1/4" brass rod. These are all just things that I had lying around. I might get something different for the final version of this project, which is going to be months away, because now that I know I'm going to use these 12 volt solenoids instead of the 5 volt ones, I've got to order a whole bunch more of them. But in the meantime, let's find out what we think about the sound of these things. For the experiment, I've just drilled some holes into the ends of the solid rods and put some fishing line through it. And the threaded rod, I just clove hitched a piece of fishing line around it. That way it's suspended and it can ring freely, rather than if I'm holding it, that's going to dampen the sound. Hopefully we're close enough to hear this when it happens. That's quiet. Did you even hear that? Let's try the steel one. Oh, that's better. Oh yeah, that's good. Not so much. Stop moving. That's pretty quiet. Well, I'm hoping you were able to hear that. but to my mind, this 5/16 steel rod was definitely the best choice. So a couple of other things that I've got to figure out here. I'm going to need to mount these things, which should be straightforward because they have holes drilled in them already, which are at a spacing that I can measure. It's 4 millimeters that way, and so about 5 millimeters that way. So that should be very easy to CAD. And if I look closely at those, they are threaded. After digging through my screw collection, I find that those are M2 screws, so they're mountable. So let me just quickly go and CAD something up to mount these on, and I will be right back. Well, that worked out pretty well. This may not be its final form, but I've got those in there and a bit of spacing between them. I'm going to have to figure out how to mount this to something else, but at least they're held in place and they're held straight. So that's good. Now I want to cut that rod up into approximate notes. And that's going to take a bit of research online. After a whole bunch of searching, I landed on this delightfully ancient-looking page. And you can put in whatever type of scale you want. I'm just going to go with major pentatonic because it's a standard scale. And you tell it the longest chime that you want in units. It doesn't matter. This isn't going to create actual concert tuned notes. This is just going to create a relative scale, which is fine. I tried using my tuner app on my phone to try and figure out what note this rod was making, and it was just all over the place. It couldn't figure anything out. So I'm just going to go with this because it's not going to be playing with anything else. It doesn't need to be tuned to anything else. So I just arbitrarily said 12 units and get chime length, and here we go. The one note in the scale is going to be 12 units, the major second, major third, perfect fifth, major sixth, and the octave. So we have 6 notes that we can use. So after a bit of head scratching, I dropped those into a spreadsheet. And this bunch here is literally just those notes directly, or those lengths directly out of there. And then I did some math, add them up. That comes up with 61 units. Then I just experimentally came up with a constant, just a number to use. And then in each one of these, I multiplied them out to get some lengths until the total of those lengths came up to just slightly less material than what I've got. Because I didn't want to have to go and buy another stick of this material, because I'm cheap that way, and I'm just doing this mostly with stuff that I got on hand. Initially anyway, right, for the experiment. But, so that comes up to 770 millimeters, and my stick of metal is about 800 millimeters long, so that lets me cut them a hair long and then grind them back or file them back to get those exact numbers. And conveniently, the longest length that my caliper can measure is 156 millimeters. So starting with 150 millimeters as my longest chime, I can zero them in precisely with this. I don't have to use, a tape measure or something like imprecise like that. So I'm going to start at the end that I've already got the hanger hole drilled into, and I'm going to go a little bit long so I can file it back to the exact length, because I don't know what the kerf on my blade is going to be or anything like that, or how accurately I'm going to cut it. Let's see how much I have to shave off this thing to make it work. Well, that's about the level of precision that you've come to expect from this place, isn't it? Right, so what I will do is adjust the spreadsheet to make the rest of them fit with that and not be horribly janky out of tune. But for now, I'll just temporarily hang that up there so that we can see how this works. I'll start that up again. You have to alignment's going to be an issue. Also, where do I strike this thing because it keeps moving out of the way? There's one that I'm going to need some design help on. Well, I don't know what to do about this problem. My project is kind of grinding to a halt here. Do I do some sort of a lever so that I've got a lot more motion when I strike it? Maybe? Well, this got janky in a hurry. Not that it wasn't already. I wonder if something like that would do it. Or maybe these solenoids just don't have enough throw even with the servo horn amplifying the throw and this really long stick. I don't know. I think this is the point where I'm glad that I didn't order more of that solenoid. And I may go back to searching and seeing if I can find some better solenoids, and possibly with a longer throw. Not quite sure what to do about this problem though, because it sounds nice, but you know, it's never where you want it to be. Anyway, yeah, I think I'm going to call it for today. Unsatisfactory ending, but I learned a few things, and I successfully modeled something first try. I'm pretty pleased about that. Yeah, I'm going to turn it over to the comments section and see what wisdom I can find down there. Do you know of any longer throw solenoids that work on relatively low current, like half an amp, 5 to 12 volts or less, and cheap because I want to buy a bunch of them? Any idea how I solve that problem with this thing not staying where I put it? I mean, yeah, I know I got to get some movement in order to get sound out of it, but I'd rather not have it going that far afield. Or maybe is the solution to my problem not going with a hanging chime and instead going out and buying a cheap kid's xylophone to modify. I don't know. There's got to be a solution to this problem. I'm open to all creative ideas down below. We'll see what happens, and I do plan on revisiting this because I am intrigued by going electromechanical here. I just don't know exactly which direction to take it. So if you've got any really good ideas, drop them down in the comments. Thanks for watching, and I will talk to you later.